Hello everyone, let's wait a little more and it's time to start. Okay, let's start. Hello everyone, so welcome to our Saturday session, and the plan, as I said yesterday, will be, so it's scheduled that we have 5 hours, that's correct, but the idea is that we'll have just a usual 3-hour session until 12 p.m. and after that you will have the individual work on the home task. So today I'll give you the first home task. The deadline will not be today or this Monday. I will provide it later today, but you can start doing it today. And yeah, just as usual, in case you need to contact me, you can do it. But before that, we will finish the topics. We'll finish the topic about syntax, some basic syntax things used in Java. Then we will have the practical task from activity 03, this one, .NET, and basically, yeah. So this is, I'll show you how these activities can be done here. Basically, how to work with them. Yeah, okay. And yeah, then you will know how to proceed with these activities. 1 minute. Okay, so let's continue with the syntax. We finished with the array resizing yesterday, and yeah, as you know, and as you know, we have the arrays in Java with the fixed size. So it means that when we create the array as the object, we provide the size to it, and so after that, the size of the particular array cannot be changed. Otherwise, if we need to have the array with different size, then the only way to do it is to create a new object, new array. So in this case, please remember that that the arrays are the objects and the reference types, and the idea of the reference types is that we think first we think about the reference, not the value. So it means that the value itself is the value stored under the variable is the reference of this array, of this object. So it points to the array in the memory. So yeah, and it does not store the value. So like you have the array of six elements. So the variable here do not store the elements we have under the array. It stores the pointer, the reference to this particular object created here in the memory. So first so if we want to work with the array, first we create the object, we pass the object to the variable, and so here it is the variable, and to access the elements, we actually first since it stores the reference, it points. So we access the location in the memory, the spots where our elements are stored, and then we work with the elements there. But the elements themselves are not stored under the variable. Only the object, the reference to the object itself. So it means that basically in this case, how it works, that we have the variable. So as for all the reference types, this is the place where we store the references, as I said. And it means that we can also here we declared that the variable will store. Please note that we declared that the variable will store the array of integer, and the size is not defined, and it should not be defined because this is the type. The type is array of integers. And then as for all the variables, we can pass different values, and it means that we can pass, in this case we can pass different objects. And like in this case we can see that we can pass integer with 6 elements, integer with 10 elements, and so on. So basically we can pass any array, any integer array with any size. So and again, the array is the object. So all the walls we have for the reference types present are here with the arrays as well. And so in this case we should also think about the copying. And here I will provide just a simple example, maybe I'll create a class just to not store everything. Not store everything under the same class. So what's the point? Imagine we have the array, again I would say the array of integers, and then we, let's say the array was 5 integers, and then we just oh yeah, sorry. And let's add the element. Let's assign the values to the elements. So just assign the values to the elements and what's the idea? Now I have the array with the elements, and I want to copy it. And so if we use the simple primitive types, how it usually works, we just declare another variable, and yeah, basically in this case we when declare another variable, how we usually do, we just assign the previous the value we want to copy the array. This is how it works for primitive types, but you'll see not for arrays. So as I said, the arrays are the objects. So I can make it print. Okay, let's just create a method. Use the programming we did not export before. Just print the array. Which will just print the array. So we can compare two arrays. I use print. And I'll print the elements of the array, and then I will separate it as well. Separate them by spaces. Okay, and in case I want to change something in the second array, like it's going to be the fifth element. Plus I minus 4 as an example. Then if I print the second array, then we'll see that so let's just return the string. I just printed, that's why we cannot have the returning tag. Right, and so you can see that we changed the value in the first array, in the second array, but we will see that changes will be reflected in the first array as well. That's because we passed the reference, so it means that at this point array 2 and array, just a simple array, they are the same, they have the same objects stored under them. Stores the same reference as array does. And that's why if we change the values of the second array, the changes will be reflected in the first array as well. So this is the concept how it works for all the references. So in this case, when we work with the references, again, any non-primitive tag, it's the array or any class you have, then please note that if you work, if you pass the values this way, then it means that you pass the reference, so it means that you will store the same reference here. The only difference is that we have just, between array and array 2 is that we have two variables, but we have one object for both of them. And in this case, the copying will not work this way. So this is not open. A little bit later, for the we did not discuss it in previous course, but we'll see in this course that for the objects we have such thing like cloning. So we will explore the cloning a little bit later, but just maybe right now for you to introduce it a little bit. If we have the objects and if we want to copy the object, we usually call it cloning. So it means that we have one object, we clone the object, and after we clone the object, we actually create another object with different reference. So it's different object right now, but with all the same values copied from the previous object. And this is called cloning in programming. For arrays, that's for arrays can also be called this way, but there are some different tools. Like in this case, you can see that system array copy. So in this case, can call the method array copy. So that's the void. It does not return. It does not return anything. That's why we can just simply copy it this way. So then to the source, I need to provide the source. So this is to copy the array. So I provide the source will be the array. Then just copy it. To not repeat the code. So then I need to provide the position and from which we want to copy. So we start at 0. Then we provide the destination and want to copy the array to array 2. And so again, from where we start. We start from 0 position, and the length is just the length of the array. Okay, yeah, for some reasons it requires us that the second array should also be initialized. Maybe I think we cannot initialize it with no. Okay, let's quickly check it. So then I change the value of the second array, and then we will print the first array. So a moment, let's quickly check it. Yeah, we cannot. Yeah, so we need to provide the size of the array as well in this case. So that will be integer, and so we should mandatory. So in this case, we can see that the array is not changed. Yeah, so this is also the point. Before we copy the array, we must define new object. And so in this case, you can see that we changed the value in the second array, but it is not reflected in the first array. That's because right now we have. Let's print line separator. And right now we see that we have two different arrays, and they are not the same. Not the same as at this point. Yeah, and basically how this method works, you can see that again what these two, basically these three values mean is that we provide the position at which we want to start. So here we say that we start at the 0 position in this array, and here we say that we start at 0. We start taking the elements at 0 position at 0 position in this array. So we start from 0 in array 1, then we get this number of elements on the length of the array, and we pass them to the corresponding position starting at element 0 in the array 2. So this is the way how you need to copy the arrays directly. But again, as you know, that as you can see here, just to copy the array, we actually change the size of the array. Then we actually need to create a new array. And maybe as an example, I will show you how can we add any new elements to the array. So in this case, that would be to create the add new element to the array. So in this case, we have we can create method. And this will be add element to array. So to do it, first I need to have the array where we want to. That will be, of course, the returning type is the array, as we want to return the array from this method, which will have the element we want to add. And here I have the element to add. At this point we'll add the element, and so first of all, what will I do is I will create a new array with a new size. So that will be new array, and this would be an integer, and size is the size of the array plus 1, right? Because we want to add one element. We want to add new element. So the size is I'll say plus 1, I have to understand that. And in this case, first we need to, so right now we have a new object, new array with all the elements are zeros. And so, in this case, we need to copy the array. And okay, let's copy the array. So the source again is the array. Then the source position, basically again we start with 0. Then we set yeah, we can add it at the end of the array and the end. And also we can add at the start if we want. We will create this set in another method as well here after this. So again, we start with this first position. Then we provide the target. Target is the second array, new array. Again, we start in 0 position, and then we provide the length. The length is length because we just copy the length is because we copy only elements and we do not copy, we just have one element to copy. And after that I will add the last element, and the last element is the element we want to add. The last element we add. And yeah, after that we just return the array, and let's keep it as is, and I will add the element here. In fact, let me think. Yeah, we need to return the element. So let's do it. Maybe in this case I can do it this way. And I will add the array, and we will add let's say that the elements 20 example, and we will see the result. Nothing is wrong. Okay, not sure where did I import it, but it's in for us. And yeah, here you can see that let's product the array here and to put one separate result. Yeah, here you can see that we added one element to the array. In this case, this is different array because we resize it, and that's why we have a new object here. And we added the element again. In the same way, I will also show you how to end. The same way, I can also show you how can we add the element at the beginning. And in this case, this part is the same. We create new element, and right here the difference would be that we here that we here start not at the 0 position but at position 1, so the second position. And here we add the element right here, the first element. On the array. And let's see how this works now. So maybe I can update the beginning. And right now this will be let's say minus 34. Just for the change. Yeah, to the start of course. Start. And let's see what do we have here. Again, line separator, so we forget about it. And yeah, we can see that now we added the element at the beginning. Yeah, using this parameter, so we point where we want, from where we want to copy the array. And yeah, so this is the way how actually also the array widths work. That basically we create new object with different size, with new size, with new element. Alright, and the last thing when we talk about the syntax is the class Java-13-2. In previous course we already work with some tools from this class. Usually that's needed for mathematical related things, but just in addition, we know that computer science is related to the mathematics in a direct way, especially for those who work in the fields like cryptography or some kind of security providing. That's why we need to write some codes which need to hide and secure the information. And this in these cases we need to do some calculations, also with large numbers, and to provide some security. And in this case, Java-13 class can be really helpful. With all these functions first, but in addition, what I want to highlight here, I mentioned just examples. I mentioned yesterday is so-called big. There are some classes from this package, and the classes are, for example, big integer. So this will be a very large integer, and so since this is the object, we will work with it not as with the integer, but as with the objects. So this is the class which works as the usual class in Java. Not like the primitives, not like the integer class, or even more primitive type. Yeah, so this is the class, big integer, and we can use it to work with large integers. Integer is the class work with a large integer, large range of integers. So I think that in fact it is unlimited, as I understand. Okay, this should be unlimited. Yeah, this should be unlimited. So in this case, we can provide any number, any integer number. Like if we have something like this, here, maybe just run the number here, and so I'll declare it this way. So we can, okay, like I said, and yeah, if we use another one, basically any number of digits here, and here I can define a sum, and here I can do some operations with the integers. And please remember again, you cannot work just as we previously worked with integers. Let's define it this way. You cannot pass integer, big integer to integer. Okay. Pass big integer to integer. Since these are the objects first, these both are objects. The objects, they use the classes. And the classes are not related to each other. And in this case, so print the result, and you see that this should work. So basically the calculation is done here. So in case we want to work with such large numbers, then we can use big integer. In this case, it has no one. I can show you what I done in university once. I work with these big integers in one course, and I can basically show you the numbers I was working with such course using big integers. So a moment, I will show you. Yeah, so I had to work with prime numbers, and in this case I was working with such numbers, and then just had some results in between. So you can see how large numbers can be, and we can work with using big integer class. So in this case we have, I would say, no limits. We can work with if we want to do some calculations. So we can do some comparisons, basically any operations. But of course, please remember that, like in my case, when I work with such numbers, then it may take let's say, significant execution time of your program. In this case, that's quite simple. That took us just some milliseconds. But when you work with such numbers, then it may take maybe some minutes or even more the hours to execute your program. And sometimes, it's possible. Okay, this is what I wanted to say about Java lang math. So in case you need to work with large integers, these unlimited integers, then you can use the class. Here we have, just maybe before we finish, here we have, with this topic, here we have some operations that used add, but the same way you can multiply, you can divide, all the operations you want to work with. I think there's also big decimal as well. for big decimal, we can also do such logic. Alright, and yeah, I already mentioned, but just to remind about string class. String list is the class Java len string used for the strings, basically the set of the list of characters, the sequence of the characters. It's widely used in Java as just basically to store the text. In Java we also have, it's not mentioned in the presentation, but we also have string buffer and string builders. That's related to the performance and to the memory, of course, because strings are immutable objects. So in case we want to do some concatenation, for example, so we change the string, please remember that the string is also the in some way that's also the array of characters inside. And if we want to concatenate the strings, it means that we actually create a new string with I'd say different array, with different size, with new size. And in this case the size has changed as well, so there are some questions about the memory, about the performance used in this case. So what does it mean? It means that sometimes it's not so efficient to do multiple concatenations. Like if you have a loop with say 10 or maybe 100 iterations and even more, then if you concatenate, if you mutate the string inside, it basically means that every time you just create new string, new object. And in Java we have more efficient ways to use it, to do it. And to do it we use string builders and string buffers. I think today when we have practical example, we'll have string builder. So I will show you how to work with string builder and string buffer. But yeah, please remember that if you do some concatenation, multiple concatenations in loops, then you should not use strings. At the end, yeah, of course, when all the concatenations are done, you can get a string as the object, as the value, with the value, then use it as a simple string. But when you mutate, it's better to use string builder or string buffer class. This is the example of the operators. Yeah, there is the operator was used for concatenation. Yeah, like in this case, we just have one concatenation. That's fine. But again, if you do it in loop, then you should not concatenate in this way. Also, we can use /n, that basically puts us to a new line. I also, as you've seen, I usually use system line separator, because in different systems that's maybe different, and just to not think about it, I use this method which provides me the actual line separator I have in the system I'm currently working in. And using the constant, we can concatenate strings. So for strings we have some operations. Since the strings are the objects, we can work with them as with the objects. So it means that if we call some methods, we can get different values processed in some way, and so we can change them as well, using to lowercase to uppercase, or change the cases of the letters inside. We can trim as well if needed, substring, check the elements at the corresponding positions using the index char at. Using char at, we can compare the strings. One of them can be larger than another using the alphabet and so on. Oh yeah, and here we have string buffer. I already mentioned that. I forgot if we have it. Yeah, we have them in our presentation, so it's really good. So yeah, we use string buffer and string builder to actually build the string. Yeah. As I said, we want to build the string. We're using some multiple elements, like we have the logic which builds us the string. As maybe the simple example would be that we have the e-store, store website which has the store. So you add some products to the basket, and at the end, once the basket is filled with the products, the client wants to order what it is inside the basket, and so the client presses order, and then the message, maybe SMS or the email, are created. And so you need to create the text from what you have inside, but so it means that you need to create you need to put all the products inside your text, basically all the information you need to collect to build the message to be sent to you, like an email or an SMS, and then you need to build the text. And in this case, we need to collect information from different sources. So you build the text, and to build the text, we can use in Java we can use string buffer and string builders. So these are not just a simple string classes. Like we cannot do the simple assignments of the strings there, just as we usually do with the strings. And we need to work with them as with all the other classes. So it means that we have the methods where we can insert, append, reverse, set char, and so on. And yeah, also for string builder, their functionality is I would say almost the same, with the difference that string buffer and string builder is fast, but it's not thread safe. We'll not talk about threads at the moment. Just maybe for you to know. So usually string builder is a little bit faster, but not thread safe. So yeah, in our course we'll mainly use string builder to build the strings. And yeah, as an example, we have the loop with 10,000 iterations, and every time we need to add the character. So in this case, please remember that string is immutable. So every time we actually copy the previous object and we add it to a new place. So in this case, that's not so efficient from the performance point of view, and the proper way here would be to use string builder or string buffer, as I said, and then we add new elements to it using append. So we append it at the end of the string object, string buffer, and we actually work with the string. Yeah, we build new strings. Okay, the last thing I want to show from this presentation is about the code guidelines. So we have multiple guidelines in Java. I already mentioned some of them, like the naming of the packages. Please remember that they should be in lowercase o. Then for the classes, we have we name them starting with uppercase letter. For the variables we start with lowercase, but then we can use uppercase letters as well. We use camel case. For the constants we use uppercase letters and underscores and so on. So please take a look on the guidelines. And again, why do we need them? To improve the readability of the code. Again, if other people work with your code, then it should be quite understandable for them. Also for the version control, as well, for maintainability. In different projects that's maybe different, but yes, in general, guidelines are provided, and you can take a look at them. Also the code formatting I mentioned many times. It's important to format your code to read it. Just one thing before we finish with it and go to the break. The code format, another thing used in JavaScript for web development mostly. It's so-called code minification. It's mostly used for web development. But just let me show you. But the idea is that you write the code. Okay, that's not sure if you can see it from here. You can see it from here. Basically, when you write the code, you may have. Sometimes you may see that you write the code, you deploy the code to the system, and you can see that your code does not look the same way as you written it before. It may be so-called minified, and this is used mostly, as I said, in web development to increase the performance. So it reduces all the things which do not which are not needed for the execution of the program, like the comments, like the large names of the variables. So the minified code may have the smaller names of the variables, have less spaces or even no spaces which are not needed, which we write for to make the program more readable. Like in this case, we add the comments, we add the line breaks, but in minified code, all these things will not present. Just to increase the performance, and for large programs this may be significant to not have large code, but for small codes that's not so important. I'm just saying it because you may see some need in real life. Okay, let's have the break now, and after the break we will continue.
Okay, let's continue. So yeah, we finished with this presentation. Now, in case you have any questions, please ask. And right now, as I promised, I will show you how can we do the activities and I'll show you just one example. We will go through the activity of black light and we will do it. So first of all, how to read what should be done. Inside the activities again we have several options. First of all, what you can do is you can go to auto-van, open corresponding activity, and okay, in this case there is no mention. It's not mentioning what to do. So you can just briefly read the comments here. So in each file you should have the comments what you need to do inside here. So when you navigate to black light, then you can see what should be done. There can already be some variables, some methods declared. Sometimes we need to add more methods. It depends. So yeah. So yeah, just need to follow what is asked to be done. You can read the comments, class variables which are shared between all classes. So these are all static variables, and some public, instance variables, instance attributes, non-static attributes, which are shared inside the objects only. They are not shared with other objects. So, first of all, what we need to do? We basically need to implement what is written here. And first of all, we go to the set. We just go from up to bottom and implement what is requested here. So first of all, what we need to implement is set bottle method. And yeah, so it says initialize array of nuts with the past size. So it means that class, so I access the variable and I initialize it with the so this is the array, so I need to initialize it with the size provided, and the size is initial number. So it says here array, and to initialize it, and reset total numbers of total and live nights to 0. And I will also do it to 0. And that nights to 0 is gone. So we initialize it. Let's move down, and here we have the next requirement. First of all, we need to set proper count of yeah, so this is the constructor, as you can see in the class is black knight. We have public black knight, so this is constructor, so we construct the black knight. And so first one initialize the name, and it is here. And yeah, you need to set proper count of his arms, legs and head. So it makes sense that it should have 2 arms at the beginning at least, then 2 legs and 1 head. And yeah, set his status to alive. So this is what should remove. Set his status to alive. So we point that this this object, this knight, is alive. Okay, this is done, and here it says put reference of this knight into next free cell of not static array. Okay, so so I have static array nits, and I put it at the last position. So you can see this position starts at 0, so the first one will be 0, and then the next one will be 0 plus 1, so we need to increment the number of total nits. So total nits starts at 0, and then we increment it. So it means that the first one will be at the 0 position, second one will be at the second position, and so on. Okay, and same for the y. And so we start at 0, and then we increment it. So basically here it points to all the knights alive. Okay, this is done. Okay, let's move on. And here we need to cut off the arm of the knight. So to do it, I need to cut off. So it means that I need to decrement the number of his arms. By default, it has 2. It's all people, but if we cut off one of the arms, then that means that we should decrement it. So, but what can be the problem? The problem may be that the knight do not have any arms already. All the arms are off, and in this case there's nothing to cut. So first of all, and again, another option can be that the knight is already dead, so we cannot basically do anything with his arm. So first we need to check if the knight is alive. And I can write in this case this way. I can also use this approach. There is no difference. So if the knight is dead, then as it says here, we need to return the corresponding string. Only chicken beats that. Right? I can use else if, I can use if, it doesn't matter in this case. I can use if or else if there is no difference in this case. In this case, because return is used. So since we use return here, we will not continue the program after that, and that's why I can skip using else if. I can use if. Okay, then the second option is that there are the arms to cut off, and so it means that the number of the arms is greater than 0. It means that we have something to cut off, and this is what's how to cut off the arms and return the string mentioned here. And the last case is that we have nothing to cut, so we need to return this string. And yeah, by default we have nothing to do else. Right. Alright, so this method is done as well. And let's move on. So this in absolutely the same way, we need to cut off the leg of the knight. So first of all, again, I check if the knight is not alive, then I return the string and to nothing after that. Also, if there is wax to cut, I decrement the number of the wax, and I return the string bollocks. And else, the same way as here, I return and yeah, this is it for this method. And I need to return. Yeah. Right, and then the last of the method we need to implement is cut off his head. Yeah. So first of all, and here again, we need to check if the knight is alive. If it's not alive, then again there is nothing to nothing to cut off because the knit is already done. That. So again, I will same thing. If the knight does that, then I return the string on which it can beats that. Otherwise, if there is the head, then I need to do the following logic. First of all, I need to cut off the head. I can assign 0, I can decrement, there's no difference here. I provide the information that the knight is dead, so it means that false, he's not alive anymore. And in addition, I need to. So remember that we have the statistics of all the knights in the battle. So there are total knights which will not change during our program, because the number is fixed. Yeah, we have total knights, and what can be changed is the number of alive knights and dead knights, because again during the battle they can be killed. By default all of them are alive, but if one of them is that, then these numbers should be changed. Of course, it means that if the knight is dead, then we need to reduce the size, decrement the size of knights alive, and increment the size of knights dead. So in this case, again, this is not this. This belongs to the class static variables, and so I need to decrement the number of knights alive, and increment the number of knights dead. So this is it here, and after that I need to, it says here, if knight is alive, okay, that's done. If there are other knights alive, then I need to return. First I need to check it. If there are knights alive, then I need to return. So you will never win. So it's this string, you will never win. And after that I need to provide the name of the names of the knights alive, but at this point I cannot do it because I do not have the method. So I can create the method. As you can see here, I need to provide the names for all the knights alive, and I can create a method which provides me such information. Knights, all the names of the knights alive. So this would be private string. I will return these names as the string, and right here I will use string builders because we need to concatenate all the knights alive. So I'll use string builder. So we cannot just simply assign such string to string builder. It will not work this way. What we need to do is we need to create string builder as the object. Okay, for some reason, okay. String builder, and provide the empty string. In fact, we can provide empty string. We can start with just nothing. That's fine as well. Okay, and yeah. Also, we need to have the delimiter to delimit them in our code. So we delimit here, and by default that's just 19. And right here I go through all the knights. This should be the object, the array of all knights. Alright, and so here I check if is alive. Then I append name of the IP I use delimiter, just to delimit them, and I need to know his name. So the name is here, and I need to change the delimiter because the first time we have nothing here, but after that we need to have comma and space. So this is what I will add here, and at the end, so I have the string built here, and I return the value as the string. Right, and here I can call the method and get this value. And also it said here was still part. And otherwise, if there are no that's allowed, then we can return you will burn in hell forever. Okay, and I think this is basically it, what we need to do here. And right now, so once we're done, we can check the unit test and see if there is something missed in our code. If there is something missed, then we'll see it. Okay, you see that something is wrong, and here we can see the output of what is wrong. And here we can read what is written here. It says wrong response. Let's just read it this way. Wrong response. Okay, we can check it this way. Then you can double click and compare what is missed here. And what I see is that that we don't have space here. So it has the format that we have the space before and the space after the string. So I think that I missed the spaces here. Right. So I can add them. Let's see the result now. Alright. So yeah, and we'll test the screen. All the things are green. So and basically in UA, how would you need to do it? Is I said so the task is done. Then you create the screenshot of the unit test. Screenshot of unit test, you drag and drop it here. Drop it here, and please also name it properly. So I will do it myself. So this is unit test. Work. After that, I will need to so it's done, and yeah, so after we finish with all the unit tests, you can push the code. Plus is So this way. We should proceed this way. Alright, and the same for other tasks. So the home task for the this will be next Monday, not this Monday, coming but Monday 15. You'll need to finish activity 03, so you need to create, you need to implement array activity and random person activity. Okay, let's really quickly check. Yeah, at this point that's should be fine. I will write the home task in the channel. This would be the 15th of March. So, this is so I need to finish activity 3. So these are the tasks array and the random person. Yeah, this is home task. You will be able to start it today after this session. And yeah, again, as usual, any questions, please contact me. Alright, so this is about practical tasks. If you have any questions, please ask. And right now we can move on with the presentations. And yeah, now we start talking about object-oriented programming. In the previous course, we covered concepts of object-oriented programming, some basic things. How should we proceed with the objects? And now we will have a little bit of repeat and also some additional things will be covered here. So first of all, please remember that when we talk about object-oriented programming, we think we have the idea it's about nouns over verbs. So it means that we do not just follow the procedures one by one. We do not write code one by one. We have the objects. We have the objects. Each of them lives its own life, with the parameters, with the methods, with different behavior based on the properties located under the corresponding object. And when we talk about the object-oriented programming, we have several terms to use. First, for that's classes and objects. That's the main term, on which object-oriented programming is based. We have the constructors to construct the objects. We have the members of the classes. These are the attributes and the methods. So the attributes are the variables, and the methods are the procedures, the functions, which allow us to do some actions with data provided. Next, we have the abstraction. Abstraction, that's the feature, I would say, feature of object-oriented programming. So when we talk about superclasses, subclasses, inheritance, And yeah, polymorphism as well. The idea is that we abstract the classes, abstract the objects, so we create hierarchy of them. And yeah, general design principles, what we need to follow in object-oriented programming are that we have so-called top-down design. We'll see what is it. We go from more general to more detailed, and some properties we want to achieve are high cohesion and loose coupling. I will explain what these terms mean, and then we can also have the composition of the classes. So means that one object involved one class is located under another object of different class, or even on the same class. If the class can contain the classes inside the objects with the classes inside, the same as we had here in Black Knight. So we have the static variables which contain we have one array which contains all the knights of this class. So basically we have the variable Black Knight, the array of Black Knights located under the class called Black Knight. Alright, that's one. So the main terms are inheritance. It means that with one class inherits another class. It means that it acquires the properties of another. So we have a superclass, then we have a subclass which is inherited from the superclass. So it means that all the public and protected attributes are inherited and can also be used. Attributes and methods can also be used directly in the subclass. In fact, in addition to private attributes can also be in some way used for the subclasses, in the way that please remember that what we can do, we can call this superclass, the implementation of the methods of the superclass in our subclass. It means that if we call the implementation of the superclass, so it means that the methods implemented in the superclass will be called. And so once these methods are called, it means that these methods can also access the private attributes of the superclass. So in an indirect way, as I said, first we can access private and public attributes, but in indirect way, using the methods implemented in the superclass, we can also access private methods and attributes defined in the superclass as well. And yeah, this is the topic called encapsulation. I mean, when we talk about the way we hide the data or restrict the access to the data, is that we define the attributes as protected object or private or default, if the default, so it means without the access modifiers. And this is the way how we can drop data. Basically, we can encapsulate. Also the abstraction. As I said, that's methodology when we need to hide some implementation from the user and only provide the functionality. Yeah, that's correct. Because some classes have the methods which should only be implemented in the subclasses, and in this case there is no need to provide just any dummy implementation. In this case, we can just define the method as abstract and then implement it in the subclasses. Then the polymorphism, that's the ability of the function to take, or object to take multiple forms. Also that's related to the inheritance. Because when we pass, when we do the casting, for example, or we work with the abstractions, then we should definitely, then there's definitely the polymorphism will be used. Some different implementations of the methods present here, and this may affect the result of the code. Alright, the first thing what we have is the class. Basically, the class is present in all the object-oriented languages. The same you will see if you work with C++, C#, JavaScript, PHP. I'd say in almost all the languages where the object-oriented languages, because please know that not all the languages are object-oriented, but most modern languages are. And there are the classes. And which define the behavior of the class itself and of the objects, which are referred to this particular class. And the idea is that the class is used as a template to create similar objects and handle them in a similar way. So first of all, we have the modifier of the class. So it restricts the access to the class, and we can have private, we can have public class, or not a simple class, default class. It means that the access can be different in different places in your code. The class keyword defines our class name. We always start in uppercase, but we can use so-called camel case. So it means that not actually camel case, but the idea is that if we want to separate different words inside, then we can use the uppercases in the middle of the word. And the pair of braces points to the start of the code and the end of the class. Java supports such features like encapsulation, inheritance, and polymorphism. For different languages, also the object-oriented languages, the approaches used may be different. Some of them do not use encapsulation. I think we can say this for JavaScript as well. So just be correct, not to lie to you again. That's for JavaScript. We can call that there is that's done in a little bit different way in JavaScript. But never mind. For Java we have a classical way. Just we hide the data somewhere. We wrap basically. We wrap the data in some way. As I said, for class naming conventions we can use camel case, and we should start with uppercase. Here's the example: decoration, modifier, class keyword, and then the name of the class, and then we have the attribute decoration. So we have the attributes. We usually declare the attributes on the top of the class. Then we have the constructor, and the class will not have constructor in this case. Also then we have declaration of the methods. Attributes can be defined in the way, so using the following pattern. We have the modifier, default type, protected or public. Then we have the type and the name. Also we type if this is the static attribute or non-static. That's also something that's missed here. There should be static or non-static. So this is how we declare it, just on top of the class. And also in the constants. If you want to declare a constant, then you just need to provide the keyword final before. Alright, then we go to objects. That's the item of the class which refers to the class. Difference of structure, object contains both data and the methods. Because in different languages you will see such data type like structure, so it means that you have the type which has the fields. So it means that, for example, it can be the structure person details, and then will be the name. So we have so this is structure, person details, and this will contain name, surname, maybe some other basic details. So this is called structure in other languages. But structures do not contain the methods. So the structures are used only for data. So, like for example, the tables. The row of the table is considered as the structure. Have the columns, and each column represents the corresponding field in the structure. And the object, compared to the structure, object contains both the data and the methods, which define the behavior. And there could be other objects inside as well. When we declare them as when we store them in the attributes of the class of the object, and structures can be created into the objects can be created into different ways. Can we create the object, or we just use the static methods and static attributes. And basically just to know how the so basically what is the object, just for you to know, and as I said, we know that for the objects we have the reference, which points to the position in the memory where the variables are stored, and basically the variables which represent the object. Like again the arrays as an example. We have the array as the object, and it's so when we import with the arrays, we store the reference of the array, and then using the reference we can access them. The position of the memory where the variables are located. And as an example, just to distinguish classes and objects, so as I mentioned yesterday, the class would be the computer Lenovo T460, and the object is the object will be Nova with the same model number, but with the specific serial number. So this is the exact computer. And basically the question, but the thing you can easily think about, just to compare just to know the difference between the class and the object, is basically any product you can imagine. In this case the product is computer, but when we mentioned the car, that will be the car. So there can be the car with some specific model, and then when you have the exact car, then the exact car will be the object. And so you have model of the car, and we have the car itself. We can have multiple cars of one exact model. So this will be the class and the cars, the objects. Then for each class, for all the classes in Java, we have the constructors. In some cases, you do not write the constructors by yourself, but for each class there is the constructor called. And just if you do not implement anything in your class, that means that the constructor of the superclass will be called. And so it means that constructor will always be called at some point. But usually, if you want to just implement some logic inside, you need to create a constructor inside the class, and then you can build your object. Constructors are needed to actually build the object, like you have some basic parameters without which you cannot build the object, and you need to provide them. Constructors are automatically executed when you create a new object, when you use the keyword new. So it means you create the object, and then once you create the object, then the constructor will be called. The constructors are defined in a simple way, that these are just the methods without the returning type, and you don't need to pass void. And the name of them should be the name of the class you want to construct. Also, if object constructor is explicit, object is created when this is true. So default constructor is each class has at least one default constructor. If constructor is created, default constructor creates empty object without any initialized variables. With the exception if you just pass the values. So in this case, when you create wildcard, you will have the knight with the name, which is name. So in this case, if you have initial constructor, then the object will not be initial. But if you do not provide anything, then there will be empty initial values for all the attributes, and for the objects which should be for the primitives that's empty or 0, and for objects that's nil. So this is an example of how you can declare the constructors. The name of the class, you should have the name of the class, and then inside the constructor we need to provide the logic. The constructors may be overloaded, so it means that there may be several constructors defined with different parameters passed to them. So based on what you provide to the constructor, so when you call new, this will be new doc. If you just call new doc without any parameters provided, then this constructor will be called. If you create the object of doc using new doc and you pass the value to it, then this constructor will be called. If you, like in this case, that will be if you do not have unparameterized constructor, then you are not able to, you cannot create the object without providing the weight of doc. Like if there's no if, you just, in this case, do the weak dog, then you cannot create the object of dog without writing the weight. So this is the first thing, and in addition, when you every time you create a constructor, there should be such thing that all the time the constructor of the superclass will be called, and this is related to the thing I previously mentioned to you, because maybe I'll quickly show you this example. We did not talk about the inheritance yet, but this is quite important when we talk about the constructors. You understand basically the idea is, the question maybe for you, why do we always need to call the constructor of the superclass? So then I'll create the child class, and I will create the parent class. And, so this should start the parent class. And here we'll have the private string same name, and here we find the constructor when we can provide the name. So it means that this name equals and in this case we can see the problem, because we have only parameterized constructor. It means that this class, as I said, can only be constructed with using the name. Yeah. So class the object can only be constructed using the name. In this case, we see the problem that this class do not call the constructor of the superclass. In Java, it is mandatory to call the constructor of the superclass. And this is the idea, because we need to construct the superclass as well. So in this case, that should be that we call the constructor of the superclass, and we'll pass the name to it. Okay. So in this case, everything is fine. And in fact, I previously mentioned that, so despite the fact that we have this this attribute private, so when we create this object, maybe I will call it the execution class. So here we'll create child object. So create an object here. Just a name. And right here you can see that we can access the name. Okay. So, and basically what does this thing shows to us? So the name will be here and it will be accessed, despite the fact that we have the private attribute and it is not accessible from here. We can only access it using the superclass. In this case, when we use this class, we can still access them in some maybe it's hidden way, in an indirect way, how we can access the attribute defined in the superclass. And this is basically the fact why we always need to call the constructor of the superclass. Because in fact, when we construct the direct class, I mean the class we just want to create a SysJava class, we also constructed the instance of the parent class. And this is basically we go ahead with the case about the casting. Because in fact, when we do the casting, so as you know, we can cast any subclass to superclass type. That's because all the subclasses do have all the properties defined for the parent classes. And in this case, you can see we call the constructor. So it actually creates also the not actually the instance, but all the structure, the whole structure of the parent class as well. And in this case, I hope that the casting, the rules of the casting make sense for you. But yeah, okay, that's maybe a little bit in future. And now we can see such things like private or protected constructor. There can be different scenarios where the creation of the object with reference to the class, class X, is restricted. There are such cases like you cannot directly create the instance of the class. And this may be the case. There may be such case, and what does it mean? It means that you define the constructor of the class as private or protected. So, and what it actually means? It means that you can, so if you define the constructor as private, it means that the instance of the class can only be created from inside the class. Like if you are in the class dog, then you create the instance of dog only inside the class dog and nowhere else. The same similar for protected. If you define the constructor as protected, then you can create the instance of the class inside the class itself, and from all the subclasses of the class. Let's do this such example. So in this case, define the class constructor as parent. So and go to execution class, you can see that we cannot access we cannot create a class from here. Of course. Can I do it? Because the constructors. Because the constructor is correct. So, and it means that the only way to create the instance of the class is to define static method which can return us the instance of the class. In this case, we can do it this way. No. This way is allowed us because this is public method, public static method. We can always access it from the class. Yeah, in this case there is no much difference if you just create directly when you use cat instance, but in fact in some cases there may be some restrictions. For example, we have the constructor which which maybe if we have the person, so that would be person name. And we need to apply the person name to the constructor. Constructor, and from here we got pre-populated. So that makes sense, just the usual constructor. But we can add the restriction. For example, if so we can check if person name person name as well. So we can add some checks on the person name. For example, if person name if the number of characters is not zero, otherwise that's zero. No, it's not zero. No. So in this case, imply person name. Check if the name is valid. If else, we can return null, for example. So if value is not valid, we return null. We don't create the object. So as an example, we cannot achieve such check using the public constructor, because if you call the public constructor, it will always create you the object. The only way we can achieve it using public constructor is just to use the exception handling. But if we don't use exception handling, then we just we can do it this way. So in this case, we restrict the access to the creation of the object. So it means that not every, in some cases, not everyone, not from all the places in the code, can create the instance of the class. And in some cases, also validation needs to be done. So right here, some cases we need to do the validation. Will restrict the access, to restrict the creation of objects. So it's really important. And in this case, we can just simply provide the name. So if the name is something like this, then we'll see that the object should be null. Object is null. If we provide the name, then that should be the object. So the object will be created. That will have the object. So this is how can we use protected and private constructors. Okay, right now let's have the break, and after the break we'll continue. Okay, let's continue. So this is about our protected constructors. So yeah, we can restrict the creation of the objects using that. Yeah, and this is how the values are assigned using the references. So for example, here we have three variables used in our code: x, y, s, and t. We have these primitive values, x and y. So first we'll initialize x with 7, then we assign x to 7. Since x, this is the primitive type, value with this primitive type, then we just pass the value stored under x. And this is what we have. We just have x and y. So nothing special here. And then we declare the reference variables. We have s and t. Here we create new object. So we have the reference with the address 0x01 and so on. It points to the exact place in the memory where we actually store three values: 22, 7, and 1964. Okay. And then when we pass the reference, then we just actually pass the same reference divided by t, so it stores this reference, which points us to the same place in the memory. And yeah, this is how can we imagine the values and the references. So we have the reference, and it points us to the exact places in the memory, where we have the values. So this is basically what the objects are about. We have the object, we have the place it's stored in, and we have the values stored inside the object. So the accessing of object members. To access the members of the object, we use dots and the reference the object. And then we can access the attributes when we don't use the rounded brackets like this. We can access the methods when we use rounded brackets and provide the parameters if needed. And yeah, in Java, as I said yesterday, all the parameters are passed by value, so it means that when you pass the parameter, then it creates the copy of the variable. Basically it passes the value, but not the variable itself. So it means that there is a new variable, but the value remains the same. So in case you pass the reference to the method, then it will use the same reference. So it means that all the attributes you change from the object, you pass to the method, and all all the changes will be reflected. Yeah. So if our descriptive that we change, the parameters change itself, it does not affect any other changes outside parameter context. If you change the object, then the attributes you change, the object will reflect the changes in all the places this object is used. Then we have the reference. This is actually also we can consider it as the variable. The variable which stores the reference of the object inside itself. Like we are inside the class, we use any methods, we use the methods there, and then using this keyword this, we actually work with the object where we are currently in. This is current object. For object-oriented programming, for the classes, for the objects, we have such thing like destructor. You may see it in other languages like C++, but in Java, it is done automatically. Basically, what does it mean? It means that this is the internal method which is executed before object destruction. So we destruct the object. In Java, there is no such explicit destructor, so it's done by the garbage collector built in Java. So it's done automatically. We don't need to do it ourselves. There's such thing like we can override method finalize if needed, and then we can suggest collection by runtime GC or system GC, garbage collector. But anyway, objects actually destructor is managed by garbage collector, and basically there's no need to do such things. And then we have classes, we have methods. Methods can be static or non-static, and they represent the behavior of the class, of the object, and you can call them from the call. They describe actions, how behavior is performed. They hide actual implementation from invoking code. That's true for abstract classes, like not only for abstract classes, but for all the classes. When we, because in some cases, as we know, we can pass the subclasses to the superclass variables, and in this case, when we call the methods, then the implementation of the methods may be different than we actually see from the code. Again, we declare the variable. The variable is just any class. Then we pass the reference of the subclass to this class, and then we call some method from this variable, and so you can see that you call the method from the variable itself, which is just any class. So it means that we call the method from all class. But in fact, there is a different reference stored there, the reference of the subclass. And in some classes, we can override the methods of the superclass. And in this case, the implementation will be different. And in fact, we call them. This results in a situation that we call the method from the superclass, from the variable which refers to the superclass. We call the method, but in fact, the implementation of the method located in the subclass will be called here. This is about the second property, and methods can change the property, so or the state of the object, and that's true, we can change the attributes from inside. About naming conventions, the same as for the variables, we use the camel case, so start with lowercase letter, and then if needed, we use uppercase letters to separate the words inside. So Then we use method declaration. So you know how we do it. Use access modifier. Then if needed, static or non-static type. Then the return type. If not, then we use what, the name of the method, and the parameters. Then if needed. Special here. And yeah, so just to distinguish the differences, the constructors and methods. So without differences, simple for constructors we have all access modifiers we know public and private and non, which is default one. The same is for the methods, but in addition for the methods we can declare them as abstract, and so they can be abstract methods. Final, so it means that it cannot be overridden in these subclasses. Native, static, and synchronized. And these are more native and synchronized and more specific. And yeah. So the returning type, there is no returning type for the constructors. In fact, they create new object with the class. So in theory, we can call that there is the returning type, which is defined automatically, which is the class type itself. And for methods, there can be any type or void. It's not return type. The name for the constructor must be the same as class name. Names for the methods can be different. In constructor, and this refers to another constructor. Yeah. So when we call this, but yeah, in fact, using this, we can access the attributes from the class itself, and using super, we can access the constructor of the super class. And yeah, inheritance constructors are not inherited. They are not inherited because we should always call the constructor of the superclass anytime, as I just said today. Then yeah, usually we use getters and setters. Yeah, as you know, we usually for the attributes we usually restrict the access to the attributes, and we do it by defining the attributes as private or protected. And in this case, there's normal usual way how to do it is that how to access these attributes, how to set the values, then how to get the values. Then, as you know, we use getters and setters. And we need it to restrict the access, need to verify the values of the attributes, if values can be set or not, and just not allow the direct access to the attribute itself. Alright, and then we go to abstraction. In Java, we use abstraction techniques, and not only Java, but in all the languages it is used to basically not show everything. So there are different principles to manage the complexity. So using the abstraction, we can achieve the situation where our logic do not look so complicated. So in fact, it means that just simply if you have the method to do something, then the idea is that we usually do not care what this method does. I mean, not what this method does, but how this method works. We just have the fact that we have this method do something, it does something, and it does what we want. In this case, I don't care how the method print line works, I just use it and it prints me the stuff I want to print. That's true for all of them. That's true for abstraction in the way, and this is what we want to achieve. using the assumption that we don't care how the methods work. Right, the programming software abstraction deals with classes and objects, yeah, that's for sure. And they have, we already know the objects have properties in the methods, and we can manage hierarchies of the objects using them, and yeah, we iterate. In object-oriented programming, objects interacts each to other invoking their methods, and sometimes we do not want to show it directly. Okay, and one of the part of the abstraction is encapsulation. So that's the technique that we pack in data and methods into an object. And the idea is that we do not show some of these things directly from out to the places outside the object. And the difference, for example, structured programming, objects know what can be done with them as their data structures and are complemented by their methods. Yeah, so in this case, objects do know how to do the things, and we as those who call to use these methods, we do not really care about these things usually. So yeah, using encapsulation, we can hide the actual implementation. And internal private structure behavior of an object. Then remember we have access modifiers. In Java we have default public, and based on which of them we use, we will have different access to the attributes and methods of the classes. Yeah, most usual, just by default, that's default. Yeah. So we can access from the same class, same package, basically from the same package. From all the places in the same package. That's rarely used. Usually we use these three. Private simply points us that we can access the methods or the attributes only from inside the class. Protected means we can access it from inside the class and in the subclasses as well. And public means that we can access from everywhere. Right, then we go to the concept of inheritance. Inheritance means that we use the subclasses and the superclasses, and we associate the classes using the inheritance. So what does it mean? It means that if we have a subclass, that it is we can apply association as add, and here we can place the name of the superclass. And yeah, we actually base the subclass on what we have in the superclass. So why we need it? It allows us to reuse data in behavior and extend it only when more complex structure where behavior is necessary. So here is the concept for the subclasses. Then we make, so the subclass is actually also what is defined in the superclass, plus we add some more information. So that's the concept, we add more information to the subclasses. More general class or final class, as we said, or superclass, and more specific class is called child class or subclass. And as an example, bird, fish, mammal is a subclass of animal class. So, and there can be, here's the example, we have a computer class and just the model, the one set model of the computer can be the subclass of the class computer. Because this subclass will have all the properties of the superclass. This is the computer, so all the things defined for the computer can be applied for this. Can be applied, they will be applied to all the modules of the computers. And the next one is polymorphism. That's the approach when the same invocation or management is used for different behavior. For example, in the class animal, we can have the method move. So it means that we ask animal to move. But the fact is that different animals move differently. And in this case, for different animals like the birds, fish, and mammal, the method move will work differently. And in this case, we need to override these methods in these subclasses and define the behavior, define the movement there. Okay, and what I already mentioned about the classes, about the inheritance we use in Java, not only Java, but the languages is that we have so-called top-down design. It means that we go from more general to more specific, and this is why it is called top-down, because on the top of each element here we have the superclass and superparent object defined in the way that we can basically describe it in scheme using the arrows which point to down. In this case, that we need a clock is also digital clock. Date, that's also something more specific than the clock, and so on. So basically, we go from more general to more specific things. This is what it's all about. As large software systems, we can build them using following approach. If necessary, part is already created, then use it. If not, then add it. So every time we extend the class, we add something new. That's why in Java it's called we have extends keyword for the subclasses. So it means that we extend the superclass, we add some more properties there. And otherwise, split the problem separate parts, so it means that create the subclasses and put them together using the inheritance. The same approach is used in other software development approaches. Only difference in object parameters is that the structure of the objects is created. And the idea is that divide each difficulty into as many parts as is feasible and necessary to resolve it. So, the problem may be that basically the way we define our classes, our objects, our classes. Because sometimes, I would say, maybe usually, some developers may mix such things like inheritance and composition. because sometimes that's the idea is that we have the class, we have the object with the attributes, and then so under the attributes we have the values stored, right? And it means that, for example, we have the again the computer, and the computer has such attributes like maybe the processor, for example, the core processor inside. So it means that we have the object computer, and inside the computer we have the object processor. And in this case, that's obviously that processor is not the subclass of computer, right? Because the processor is not the computer; it is the subclass of the computer. But we need to find a way how to link them. And basically, in this case, the way will be that we just use the composition. We define that we have the class of the processors, and we just add we just have the attribute we can place under the computer class, right? And in this case, we do not have any inheritance or any extension. We just use them together. And so and here is the idea of things how to construct the object, think how to construct the classes, how to link them, and here we have two things which needed to be implemented, and these are minimize coupling and maximize cohesion. So basically, what does it mean? Just top-down designs, it does not guarantee us a good design, and this it will not always be. It will not always guarantee us that we will have the right design. You cannot say that design is good before implementation. Because in good design, the interaction between objects, we call it coupling, is as minimal as possible. So, for example, again, we have subclass or superclass of shape, and we have the subclasses like square, rectangle, circle, and ellipse. So it means that these classes will not interact with each other, right? Because they just linked in the way that these are the shapes. So they can only be controlled by the shape class. If we change something to the shape class, then this will reflect the changes for these four shapes as well. But if we do the changes inside square related changes, we need to do some changes related to the square class, then these changes should not affect other classes here. Only if we do the change in shape class, then changes will be reflected here. If we do the changes in one of them, these changes should definitely not affect other classes here. So in this case, this is good design, that we have four shapes, and these are the subclasses of shape class. This is a good design, so pretty clear. But bad design would be that square is rectangle. Square is rectangle. Because in this case that will be the coupling between square sizes. Because because the idea is that when we calculate the square size, for squares we just need to multiply. We just put the length of the edge of the square in square. Just need to cover it square. For rectangle, we need to multiply just two edges there. And in this case, we should not couple them. On the opposite way, we need to minimize coupling, so we need to minimize the connection between the subclass, between the classes. And on the other way, we need to maximize cohesion. So that's the principle of grouping similar objects together. Yeah? So in general, cohesion means stiffness between similar objects. Like in good software design, so that should be as big as possible. That this means that we need to find a way how to group them into the same group using inheritance and combination. Together, different objects are grouped apart. And here is an example. Good design would be that we use bird, fish, and mammal, and they are animals. Another good example would be that carrot, potato, and cucumber are plants. So that also makes sense. But the bad design would be if you just imagine your own class without any specific meaningful meaning, like my likes, and you just put the objects which are not related to each other. So this is the case how we should not proceed. And also start seeing. So here we have two objects which are not related with each other, definitely. And most other also kind of not so clear. And this would be, for example, if you so also do not think that you have, for example, the web page, and you have the view, and you have some elements here, and you just call all the elements here as the subclass of the view. That's not correct. What I said about the computer. The processor is not the subclass of computer. This is not correct. And so this is the case when we go from simple to more complex, like from general to more detailed. We have square. In this case, as I said, we can go from top to down, but this will not always make us the small component, because that was said that square and rectangle should not be linked with each other. But when we talk about simple to complex, this is the example which can be applied to this approach in simple to complex. Because the square is just a square, a rectangle, more advanced shape, and parallelogram even more advanced with the angles which are not 90 degrees. And one of the last things to talk about object-oriented programming is the composition. As I already mentioned, this is the approach when we combine many objects into one. Again, like the computer. Inside the computer we have the processor, again we have the memory, and graphical card, and all these things. So this is the approach, how can we split complex system and then solve it into another system as a part. And we can describe it as this association as has S, so it means that computer has the processor, computer has the graphical card, and so on. Composition allows code to use where different complex objects have same simple parts. It allows us to perform partial implementation and testing. Again, like we have different classes. We define class of processor, again, class of graphical cards, and we just put these classes inside these attributes inside the computer. So it means that if we do the changes in the class, we do not in the class of the processor, we do not need to do any other specific changes inside the computer class. So we only do the changes in the processor class. So as an example, it can be that car has an engine, body, and 4 wheels. So it means that these classes are not related with each other using the subclasses or using the inheritance, but using composition. And truck has an engine, frame, and 10 wheels, also example. These classes are not, so it doesn't mean that engine, frame, and wheels are tracks, but it means that the truck has all these parameters, all these attributes. So this is composition. And yeah, last two things to talk about today are, first one is, as I mentioned in the previous course already, this is called object class, because all the classes are inherited from object class in Java. So when you create a new class, you automatically extend the class object. So that's why it means that you can always cast any class, any object in Java to the variable you define as object. So it means that this will be the same if you declare the class. It means the same way that you declare the class and put extends object. That will be the same. Okay, and the last thing is to represent, how to represent the objects in Java. Represent them using the text. So by default, as you just see that all the classes, all the objects by default are represented using the references. So these are the pointers to the memory. But sometimes we want to represent them using the strings, just using the text. So if you have a computer, you do not want to represent the exact computer as the reference number, but you can represent it using the name of the computer, the serial number, and all such details. Okay. In this case, you can redefine the methods to string, class computer, and then describe it in the way you want to do it. By default, let's return to reference, but you can override it and return your own string here. Yeah, it is recommended for custom class to show meaningful object data, not just a reference. For primitive types, can be converted to string implicitly using local classes, and so they have a method to string. So all these classes can be, so it means that you can just convert the integer, character, and boolean to string using the method for the local classes. Okay, I think next time we will have we have some examples about object-oriented programming. I will prepare and show you on Monday. For now, you can start working on the home task. Please let me know if you have any questions about it. One thing as well, so can I explain? Use run operation. Is it what you mean, this one? Yeah, this section. Awesome.
This is from our home task. You could just open it and you will see.
Okay.
If you open array, it will be at the beginning of the task, and if you open the random person as well, it was mentioned in the task.
Okay. Yeah, thank you. Okay. Okay, yeah, I understand. You should inspect parameters for main method to initialize array. Yeah, that means you can use you can moment. Oh yeah, that means that you can use this main method and you can pass the arguments from the run configuration. It means from here. So as you remember, so can show it this way. So we have the array here, right? So we have the array, and we can pass the values to these arrays now if needed. We can construct these arrays. So for example, this way, I just print all the elements. If I go to run configuration, I can pass the elements here. So if I run it, sorry. Okay, that was different. Sorry, this one. Sorry, do I use this expression clause? Okay, one moment. That's my eclipse is running a little bit. Okay, so right now we can pass the arguments. Okay, this is basically, so you can see that we have these arguments stored here under the arguments variable. So basically it just suggests you that if you want to pass the arguments to the program to initialize the array. So you can use this array to pass the arguments from here. So you can pass the arguments from here. If you separate them using the space, and it means that it separates each argument. In this case, this will pass, and the program will start. With the arguments, with these 4 arguments provided here. And so this will be the array with the first, second, basically with these arguments, 4 arguments. Each argument is separated by space. Yeah, this is about run configuration. So using this one, you can pass the parameters. And about the second one, use Alt-Shift-A switch to blocks section. That's not so important for us. If you want, you can use it. I didn't use it. Just Alt-Shift-A. Yeah, it's just if you want to use it. Yeah. That's allows you to edit the list for the properties at once, but yeah, just I did not use it. So yeah, just in case you want to, use it, you can. But that's not mandatory. It's just the main idea here is that we just create the structure of random person using these parameters. And so that's, you can skip this. It's not so necessary. Just create these arguments here, these attributes here, and yeah, then you can generate the getters and setters. Okay. Yeah, source, and then generate getters and setters. So if you want, so this is the compose. Okay. this is not mandatory. I mean, if you want to use these shortcuts, you can explore them. Okay, any more questions? And if not, if no more questions, then good luck in this home task, and please ask me the questions if you have such, if you have any issues. And yeah, have a nice weekend, and then meet you all Monday. Bye.